An ellipse can be made using aligned called directories, a point called focus, and a number smaller than 1 called eccentricity. Here the number is 1/2. For an ellipse with eccentricity 1/2, we have that the distance from the point in the ellipse to the directories is twice the distance from the point in the ellipse to the focus. Each green line is twice as long as the red line. Now, here we have an example of an ellipse with eccentricity 1/3. We can see how each green line is 3 times as long as the red line. Finally, here we have an example of an ellipse with eccentricity 1/5. We can see that the smaller the eccentricity is, the more circular the ellipse becomes. One of the main models for the trajectory of the Earth around the Sun is given by an ellipse with the focus located at the center of mass. This ellipse is very circular due to the fact that the eccentricity is very small. It is near 1/60. In our solar system, the planet with the largest eccentricity is Mercury. Its eccentricity is near 1/4.86. The information displayed here was obtained by solving an ordinary differential equation. All the initial conditions needed to solve this ordinary differential equation were taken from the program Mathematica. The farthest distance from the Earth to the Sun happens at the beginning of July. By Kepler's second law, we know that the farther the Earth is from the Sun, the slower the Earth goes. Even though the information presented here is close to the real one, it is just an approximation. The model that produces an ellipse for the trajectory of the Earth around the Sun is based on Newton's law. This elliptical motion of the Earth around the Sun assumes that they are the only two bodies in the universe. Planets, stars, and in general bodies that are small or far from the Earth have no effect on this model. For this reason, it is not a surprise that Jupiter and the Moon are the two bodies that most spoils the ellipticity of the trajectory of the Earth. The maximum velocity of the Earth around the center of mass is around 30.29 kilometers per second, and the minimum velocity is around 29.29 kilometers per second. These velocities are taken with respect to the center of mass. In this model, the center of the Sun also has an elliptical trajectory with respect to the center of mass. For the center of the Sun, the maximum velocity is around 9.1 centimeters per second, while the minimum velocity is around 8.85 centimeters per second. Let us finish this video by showing an interesting fact about this model. If we were in a spaceship moving with velocity 497.78 meters per second in the direction suggested by the picture, then we will see the Earth moving with constant speed. The trajectory that we will see is no longer an ellipse. This image shows this trajectory over the period of 3 years.